Yes, different voltage systems can coexist in the same underground concrete duct bank under specific conditions outlined by electrical codes and regulations. The National Electrical Code, or NEC, permits the installation of various voltage systems within a shared raceway or enclosure, provided that the stipulations of Article 300 are adhered to. Local or regional electrical codes may impose supplementary requirements. Firstly, each voltage system needs its own dedicated conduit. Maintaining a separation of at least 6 inches between conduits is essential. Secondly, conduit fill rates must comply with NEC standards. For voltages exceeding 600 volts, the conduit fill should not surpass 40%. Conversely, for voltages of 600 volts or less, a maximum fill rate of 31% is mandated. Thirdly, cables carrying different voltages must possess appropriate insulation and shielding to avert crosstalk or voltage breakdown. The insulation's voltage grade must be rated for the highest voltage present. Metallic shielding may be necessary to mitigate electromagnetic interference or EMI. Furthermore, clear labeling is crucial. Each conduit and cable must prominently display its voltage rating. In addition to these fundamental requirements, several other factors merit consideration. The duct bank's dimensions must be adequate to accommodate all conduits while upholding the required spacing. Conduit should be securely supported and shielded from potential damage. Adequate ventilation may be needed to dissipate heat generated by the cables. Proper grounding and bonding practices must be implemented to ensure electrical safety. When considering conduit separation, the 6-inch spacing rule is paramount to prevent arcing or voltage bleed over between systems. This separation acts as a safety buffer, reducing the risk of electrical faults propagating from one voltage level to another. Regarding conduit fill, the NEC fill rate limitations are designed to prevent overheating of conductors. Overfilled conduits impede heat dissipation, which can degrade insulation and potentially lead to short circuits or fires. Insulation and shielding are critical for maintaining the integrity of each voltage system. High voltage cables require robust insulation to withstand the electrical stresses, while metallic shielding helps to contain electromagnetic fields that could interfere with sensitive electronic equipment. Proper labeling serves as a visual cue for electricians and maintenance personnel, enabling them to quickly identify the voltage level of each conduit and cable. This reduces the risk of accidental contact with live conductors and facilitates safe troubleshooting and repairs. Duct bank size is an important consideration during the design phase. The duct bank must be large enough to accommodate all conduits with the required spacing, while also providing adequate room for future expansion. Secure support and protection of conduits is essential to prevent damage from physical stress such as ground settling or accidental impacts. Ventilation is necessary to prevent heat buildup in underground duct banks, especially when multiple high-current cables are present. Over time, accumulated heat can degrade insulation and reduce the lifespan of cables. Grounding and bonding are fundamental safety measures that help to minimize the risk of electrical shock. Proper grounding provides a low-impedance path for fault currents, allowing protective devices to quickly trip and energize the circuit. Bonding ensures that all metallic components of the electrical system are at the same potential, reducing the risk of voltage differences that could cause shock hazards. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, covering a wide range of topics from wiring methods to overcurrent protection. Adhering to the NEC is essential for ensuring the safety and reliability of electrical systems. Article 300 of the NEC addresses general requirements for wiring methods and materials. This article covers topics such as the use of approved materials, protection against physical damage, and proper insulation techniques. Conduit is a raceway used to protect and route electrical conductors. Common types of conduit include rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or IMT, and rigid polyvinyl chloride conduit, or PVC. The selection of the appropriate type of conduit depends on the specific application and environmental conditions. Voltage is the electrical potential difference between 2 points in a circuit. Common voltage levels in electrical systems include 120 volts, 208 volts, 240 volts, 277 volts, 480 volts, and 4160 volts. Amperage, or current, is the rate of flow of electrical charge in a circuit. The amount of current that a conductor can safely carry depends on its size, insulation type, and the ambient temperature. Insulation is a non-conductive material used to isolate conductors and prevent electrical shock. Common types of insulation include thermoplastic high heat resistant, nylon coated, or THHN, thermoplastic heat resistant, water resistant, or THW, and cross-linked polyethylene, or XLPE. Shielding is a metallic layer used to reduce electromagnetic interference, or EMI, and protect sensitive electronic equipment from noise. Common types of shielding include copper tape, aluminum foil, and braided metal. Grounding is the process of connecting electrical equipment to the earth to provide a low impedance path for fault current. Proper grounding helps to minimize the risk of electrical shock and equipment damage. Bonding is the process of connecting all metallic components of an electrical system together to ensure that they are at the same potential. Bonding helps to reduce the risk of voltage differences that could cause shock hazards. A qualified electrician or electrical inspector possesses the knowledge and experience to ensure that electrical installations comply with all applicable codes and regulations. Consulting with a professional is essential for ensuring the safety and reliability of electrical systems. The NEC is updated every 3 years to reflect changes in technology and industry best practices. Staying current with the latest edition of the NEC is crucial for electrical professionals. Electrical codes and regulations are in place to protect people and property from the hazards of electricity. Adhering to these codes and regulations is essential for ensuring the safety of electrical systems. Different voltage systems present unique challenges in terms of insulation, shielding, and grounding. High voltage systems require more robust insulation and shielding to prevent voltage breakdown and electromagnetic interference. Proper grounding is essential for all voltage systems to minimize the risk of electrical shock. Underground duct banks are commonly used to route electrical cables in urban areas and industrial facilities. Duct banks provide protection from physical damage and environmental factors, such as moisture and temperature extremes. The design and installation of underground duct banks must comply with all applicable codes and regulations. Proper ventilation is essential to prevent heat buildup in underground duct banks. Overheated cables can experience insulation degradation and reduce lifespan. Regular inspection and maintenance of electrical systems are essential for identifying and correcting potential problems before they lead to failures or accidents. Thermographic scanning can be used to detect hotspots in electrical equipment, indicating potential insulation problems or loose connections. Power quality monitoring can be used to identify voltage sags, swells, and other disturbances that can damage sensitive electronic equipment. Electrical safety training is essential for all personnel who work on or around electrical equipment. Training should cover topics such as lockout/tagout procedures, personal protective equipment, or PPE, and safe work practices. Lockout/tagout procedures are used to energize electrical equipment before maintenance or repair work is performed. PPE, such as rubber gloves, insulated tools, and arc flash suits, is used to protect workers from electrical hazards. Safe work practices include maintaining a safe distance from energized equipment, using insulated tools, and avoiding working in wet conditions. The NEC provides specific requirements for working on energized equipment. These requirements are designed to minimize the risk of electrical shock and arc flash. Arc flash is a dangerous electrical explosion that can occur when energized conductors are exposed. Arc flash can cause severe burns, blindness, and even death. Arc flash hazard analysis is used to determine the potential arc flash hazard at a specific location. The results of the analysis are used to select appropriate PPE and establish safe work practices. Electrical safety is a shared responsibility. Everyone who works on or around electrical equipment has a role to play in ensuring a safe working environment. Firstly, voltage drop calculations ensure adequate voltage at equipment. Secondly, short circuit studies verify protective device coordination. Thirdly, load flow studies optimize system efficiency. Consideration of future load growth during design. Use of corrosion-resistant materials in underground applications. Proper backfilling and compaction around conduits. Implementation of a regular inspection and maintenance program. Documentation of all electrical system modifications. Communication of safety procedures to all personnel. Active participation in safety training programs. Promotion of a culture of safety throughout the organization.